Welcome to Mathematics Online Lecture Series, Vector Calculus, lecture number 20, Results on Vector Operators. Results on Vector Operators. Today we will discuss about a very important result. Prove that del cross A equals to del of del dot A minus del square A, or curl of curl A. This also can be written as can be written as curl of A equals to gradient of divergence of A minus del square A. So now we will prove this result. How to prove this result? First, take the inside term. By the definition, del cross A equals to I cross dou A by dou X plus J cross dou A by dou Y plus K cross dou A by dou Z. Now we will find curl of curl, nothing but now del cross A. Now what is the sigma notation? Sigma I cross dou by dou X of del cross A. Already del cross A is known. Sigma I cross dou by dou X of I cross dou A by dou X plus J cross dou A by dou Y plus K cross dou A by dou Z. Now first differentiate like our previous results. Differentiate using UV formula for each and every term. Sigma I cross. Now I is a constant vector, so derivative is 0. So just differentiate for second term. I cross dou square A by dou X square. Okay. In the similar way for second term, J cross dou square A by dou Y, dou X dou Y plus K cross dou square A by dou X dou Z. Now separate into three summations. Okay. Sigma I cross dou square A by dou X square plus I cross J cross dou square A by dou X dou Y plus I cross K cross dou square A by dou X dou Z. Okay. This is entire summation. Now you recall very important result. A cross B cross C. This is nothing but A dot C into B minus A dot B into C. Now we recall this property. This is A, B, C. A cross B cross C. Here also A cross B cross C, A cross B cross C. Now what about the terms? Sigma. First I dot dou square A by dou X square into I minus this one I dot I into dou square A by, sorry, this is dou X square. Okay. For second term, A, B, C. First I dot dou square A by dou x dou y into j minus I dot j into dou square A by dou x dou y. Now for third term plus I dot k into dou square A by dou x dou z into k minus I dot k into dou square A by dou x dou z. Okay, this is under entire summation. Okay, now simplification. Listen carefully. First term sigma I dot dou square A by dou x square into I. Okay, we will discuss later this time. Now this is I dot dou square A by dou x dou y into j. Okay, this term is also completed, this term is completed. Now I dot j equals to 0. This entire term is 0. This entire term is 0. And also I dot k is also 0. This term is also 0. Now this one I dot, I think here is no k, correction. I dot dou square A by dou x dou z into k. So first three terms are these three, and remaining minus I dot I equals to 1 minus sigma dou square A by dou x square. Okay, we will discuss later. Now simple manipulation try to understand. This is sigma. Here dou by dou x, this can be written as I into dou by dou x of I dot dou A by dou x. If you find the uv derivative, you will get the same term. In a similar way, j dot dou by dou y of I dot dou A by dou x. Again try to understand using uv formula, plus k into dou by dou z of I dot dou A by dou x minus sigma dou square A by dou x square. Okay. Now continuation. Now this is first summation up to this one. Now try to understand here I dot dou A by dou x is common term here, here and here. Now this is left hand side is curl of curl A or del cross A equals to, now sigma I dot dou by dou x plus j dot dou by dou y plus k dot dou by dou z. Sorry, I dou by dou x first term. So here j dou by dou y, k dou by dou z of I dot, common term is I dot dou A by dou x minus sigma dou square A by dou x square. Okay. Now simplification, sigma del I dot dou A by dou x. This is operator del. Now this is simply, this is del square A. Why? Del square A equals to dou square A by dou x square, dou square A by dou y square plus dou square A by dou Z square. Simply it can be written as dou square A by dou X square under sigma. This is del square A. Now expand this term. First del I dot dou A by dou X. This is first term. Second term I dot dou A by dou Y. Replace X by Y. Sorry, here there is no dot. Del I dot dou A by dou Z. Okay, this is entirely previous term. Minus del square A. Now simplification. Del is the common term. Del of I dot dou A by dou X plus this is J, this is K. Replace I by J. J dot dou A by dou Y plus K dot dou A by dou J minus del square A. Now this is simply conclusion. Del square A equals to del of inside term is del dot A minus del square A. So this is very simple. Curl of A equals to gradient of divergence of A minus del square A. Now this is most important result in vector operators. So now we will discuss about another question. What is the question? For solenoidal vector F, capital F, prove that curl of curl F equals to 0. Now listen carefully. This is most interesting result. Proof of the result. Since F is solenoidal, then what do you say? Divergence of F equals to 0. Now we will prove that curl of F equals to del power 4 F. Okay, we will discuss. First, we know that, just recall the previous result, curl F equals to gradient of divergence of F minus del square F. Here F is solenoidal and divergence of F, then what do you say? Gradient of 0 minus del square F. Curl of F equals to, finally what do you get? Curl F equals to minus del square F. Okay. Just for understanding, I will take it as some X. Say. Okay. We will discuss later. Now, curl of F equals to curl of. So inside the curl of F equals to capital X. Again we are applying this result 1. This result 1. What do you say? Gradient of divergence of X minus del square X. Okay. Now we will find gradient of divergence of X. Okay, then how to find gradient of X? Okay. Gradient of divergence of x, nothing but del dot x, nothing but sigma okay. Now continuation. Okay, first we will find the divergence of x, then we will find the remaining terms. Okay. First divergence of x. First we will find divergence of x. Divergence of x is sigma I dot dou by dou x of x. What is x? Dou by dou x of del x equals to minus del square f. Minus del square f. Okay, very simple. Now continuation. So if you common minus del square, what happen? Minus del square into sigma I dot dou f by dou x. Okay. Now this is nothing but minus del square divergence of f. Divergence of f is already known. This is 0 minus del square of 0 equals to 0. Then what do you say? Divergence of x equals to 0, then gradient of divergence of x is also 0 vector. So this term is 0. This term is 0. Now we will find from 2 and 3 curl f equals to, now what is the term? This term is 0 minus del square x. What is x? Del square of del minus del square x, del square f, because x equals to minus del square f. Then finally minus or minus del power 4 f. Hence curl of curl f equals to del power 4 into f. Okay, this is the end of our vector differentiation. In the next class we will discuss about vector integration. Okay, I will stop here. Thank you. Meet again.